everybody, and welcome to this video on number systems. In this video, we're having a look at rational numbers. Now, in the previous video, we've mentioned the different number systems that exist and their position in it all. And in this one, we are focusing on rational numbers. So what is a rational number? A rational number is any number that can be written as an integer over another integer. Please be careful that the integer and the denominator must not be equal to 0, because then we have something that is undefined. If you are looking at a decimal, and if you would like to determine if the decimal is rational, it would either have to be recurring, which means that the digits repeat and go on and on and on, or it would have to be terminating, which would mean that it stops at some stage. Both of those types of decimals can be written as an integer over an integer, and hence it is a rational number. If you would like to show that numbers are rational, you need to show that it can be written in this form. So let us have a look at some examples of this. So over here, we want to show that these numbers are rational. So we want to show that the numbers are rational. Or prove or find out, to prove or disprove whether they're rational or not. Okay, so the first few are quite easy. 3 we can write as 3 over 1, and 3 is an integer and 1 is an integer, so that means that this whole number is a rational number. Okay, so let us have a look at the next one. 0 we can write it as 0 over 1, because 0 over 1 is 0, and the 0 is an integer and 1 is an integer, which means that we wrote it as an integer over an integer. So this here is a rational number. Okay, we're still in the easier part of stuff. So this here is 4 minus 4, which we can write as minus 4 over 1, or even 4 over minus 1. So here you have a little bit of flexibility. So this here you can, and that minus 4 is an integer, and 4 is an integer, and 1 and minus 1 are integers. So this here you can write as an integer over an integer. So that means that minus 4 is a rational number. Rational. Okay, so let us have a look at the next one. 5,34. Okay, so this is a decimal. We could write it as an improper fraction as 534 over 100. And that's completely fine. 534 is an integer. 100 is an integer, which means the whole thing is a rational number. Okay, now this example here is a little bit tricky. It's a recurring number, so we can't write it as 1 over a certain number. We have to do something else. So I'm going to show you a method in which we convert recurring numbers to a fraction. So first of all, you let x be your recurring number. So in this case, it's 0, 1, 1, 1, 1, and it goes on. And then, depending on how many digits are repeating, you can either multiply it by 10, 100, 1,000. So we multiply it by 10 if one digit repeats. So here we only have a 1. We only have 1 repeating 1 over and over, so we can multiply it by 10. You multiply it by 100 if 2 digits repeat, 1,000 if 3 digits repeat. You can keep on going. So something like 0.111 would be in the 10 case, but if you were dealing with something like 0.27272727, then 2 digits are repeating. If you had something like 0.311, 311, 311, on and on and on, then you have 3 digits repeating. So depending how many digits repeating, you're going to multiply it by either 10, 100, and 1,000. So I'm going to multiply it by 10. So 10x is equal to, and by multiplying by 10, we move the decimal place once. If we multiplied it by 100, we'll move the decimal place twice, and 1,000 3 times, but we multiplied by 10, so we move it once. Then what we're going to do is we're going to say 10x minus the x. So 10x minus x, so I'm taking this one and minusing that one, is equal to 1,111 minus 0,111. Okay, because 10x is 1,111, and so we're saying 10x, which is 1,111, minus 1x, which is 0,111, as per our definitions, okay? So 10x minus 9, x is just 9x, and then 0,1111 minus 1,11111 minus 0,11111. Basically, we're taking this and we're subtracting the tail. Can you see that's the tail? So if we take away the tail, we're left with just 1, and then dividing both sides by 9, we get that x is 1 over 9. And 1 is an integer, and 9 is an integer, which means that it 0,11111 is rational. Please watch this video if this was not so clear the first time, and make sure that you understand it, because it's an important skill to show if something is rational by writing it as an integer over an integer. Please watch more videos on more content. Thank you.